Good morning, everyone. My name is Jim Chastain, and this is the ArcFlash Easy Way presentation 2025, part 4. And we're covering a lot of topics that we didn't cover in the first 3 episodes, but probably one of the things to pay attention to is the fact that you can reduce cost and improve safety at your plant as a trade-off or as a recoup of the money invested to do the study itself. As I mentioned, this is a 4-part series, and today we're going to be talking about mitigation reports, custom labeling, and then handle some questions. So first of all, I'd like to start with a poll question regarding labels. And the question is, when do you replace labels? And choices are: anytime a new study indicates incident energy has changed, every time a study is updated, or at some other interval. Again, no obligation or liability, strictly just getting some feedback from the audience and trying to broaden my awareness of the real world outside of my perspective, my view. So it looks like we have about halfway to a quorum. Let's leave this open another 15 seconds. Those attending today will receive a certificate of attendance via email. We usually get them out by the end of the week, so there's no need to do anything else. It will go to the email that you registered for or on. Okay, so it looks like we have a quorum on this question. Here's how folks have weighed in. So that's pretty interesting. Anytime a study indicates the incident energy has changed, obviously it's something that you need to replace labels. And every time the study is updated, even if nothing changes. That's an interesting predicament, and it's something that every facility owner needs to deal with, and that is, especially if you have a large number of panels, and the time invested in redoing labels can be substantial. So it's a decision that's made at the local level. There's no right or wrong answer, and I appreciate your participating in the question. And then the second question is, when it comes to changing trip settings on protective devices, who do you prefer do it? So do you expect the client to change per the recommendation you make? Or do you plan to make the changes yourself for the client, ensuring that the update has been implemented before you apply the labels? Again, another vexing decision point. And a lot of it has to do with your relationship with the client and their understanding of how important the dial settings are, the trip settings for protective devices come into play as far as the accuracy of the incident energy on the label. So we're halfway to a quorum. Let's see this open another 10 seconds. All right. So here's how folks have weighed in. So a slight leaning towards making the changes yourself. This one interests me a lot because generally I don't have to deal with it, but it's something that has to take place every time you do a study. And a lot of it depends upon the bandwidth of the client to have people and put labels in place or make changes, and whether or not they're capable or qualified to do it. Thank you for participating. Good information all. Okay, let's sally forth. So we're going to cover some questions that I didn't get to last episode, and I think they're good. Where'd we go? They're of interest to the general audience. Frequently, using scenarios is a suggested application. We're going to be talking about training and the importance of it and its standing in the safety program, get into labels, and spend a fair amount of time on mitigation. I encourage you to enter questions in the question box, not the chat window, because I will not really be checking chat. Okay, so here's some questions that I didn't get to last time. It says I've not started anything for Arc Flash. I don't have the time for webinars or software. What should I do? First and foremost, you need to find someone you can count on and depend on and trust that's qualified in the Arc Flash technologies, and then follow their recommendations. One guideline I would suggest is that you request a digital file on your system, no matter who does the study, because that's your data, and you're paying for the data collection. So the model is very useful for a number of reasons as you go down the road. The second question is, do you have to be an engineer to do an Arc Flash study? And my catchy little phrase for the day is what I call the IEEE paradox. And that is, being an engineer does not qualify someone to can do an Arc Flash analysis. Basically, it's required is experience in doing arc assessments on similar power systems. And so making sure that someone has a specific training and similar experience are mandatory. Now, with that said, if the study is part of a requirement for engineering work, for instance, it's a new design or something that needs to be reviewed, and part of the local code says that you need to have a PE stamp on that area, then yes, an engineer, a qualified engineer, needs to sign off on the results. But if you look at the steps involved, a new design is clearly engineering work, whereas data collection on an existing system requires local knowledge and training on electrical equipment, and certainly a certified electrician can be qualified to do that. Creating the one-liner, modeling as we discussed it, requires practice, but it's really a drafting type of task. And so again, you don't have to be a certified engineer to do that. Conducting the study, we just said, because the software does the heavy lifting, it's a matter of having experience in applying the software rather than doing the calculations yourself. And then printing labels is something that the tool does, and sometimes being an engineer can get in the way of some of the mundane tasks. So the answer is you don't have to be an engineer in most cases to do an Arc Flash study. I put here an excerpt from IEEE 2018. A qualified person is one who performs an Arc Flash calculations using skills and knowledge related to the construction and operation of an electrical equipment and has experience in power system studies. Okay. Now, one of the things I'm trying to emphasize in this particular episode, if you will, is the more you know or understand the Arc Flash situation, the safer your personnel will be, especially if they're trained in that regard. And so having them participate, having your maintenance people and your facility people participate in the data collection and involved in the calculations of the Arc Flash and understanding what makes the Arc Flash situation worse is important to understand. And because they have more knowledge of the system than usual consulting firms, the better trained they are in the Arc Flash process, the more value you get from your investment. So again, you save when you have the ability to make changes on the one-line diagram. When things change, you save being able to participate in the data collection and the ability to update an arc flash label, all of which can be done if you have the digital file, even if someone else constructed it. And clearly, using the tools to explain how arc flash works makes for a better communication link between you and the workforce as far as their safety training. The tool you'll see can do work permits. Having the digital file gives you the ability to do competitive bidding with other firms when you need to have or consider changes in your system. And then taking a step further in the optimization of your system by looking at the parameters in normal operations using power flow is also a way to kind of save money or recoup money that was used to invest in the study. Okay, next question. Is motor contribution relevant? According to IEEE 1584.1, which is an application note, your study should include all large motors, especially greater than 50 horsepower, and then compare incident energy calcs and equipment duty, comparing all motors turned on and all motors turned off. And I'll show you how this is emphasized in EasyPower once we get into an example, but it literally is just a one-button click to generate the results for all motors on or all motors off. So don't let me forget that. Question 4. This comes up a lot. The decision to include or exclude the main, is it based on the probability that the main breaker will fail to operate properly? Well, the answer is no. And again, this is described in the application note 1584.1. And that is, if the decision is based upon whether or not there is an arc barrier between the incoming conductors and anyone working on the bus below the main breaker. And this is an excerpt. The main circuit breakers in the switchboard and panel boards are not considered to provide arc flash protection for their switchboard or panel board. And this applies to most panels and panel boards in North America because there's no separation between the incoming conductors and the main bus that the breaker's protecting. One possible solution to this situation is to sequester the main breaker, basically move the main breaker into a separate compartment or a separate enclosure so that if an arc were to form on the incoming conductors to the main breaker, it cannot migrate to the downstream bus. Just a thought. Sometimes that's convenient, sometimes it's not. Sometimes it's company policy, and it sure makes for a safer system. Review question 4. If you have an old breaker and you're not sure of the maintenance history, and you're not sure it will perform per manufacturer's data, what do you do when you're doing data collection? And frankly, this is a task that the data collection team needs to understand, and that is they are making an assessment on the conditions of each piece of equipment that they take data on. And if they're looking at a switchboard or a breaker that hasn't been exercised in 6 years or 10 years, and it's doubtful that it's received maintenance during that time frame, there's a chance, fairly good chance, that that breaker may not operate when needed. And so the data collection team should indicate that. And in that case, you would want to exclude its inclusion in the protective path for arc flash downstream. So again, it's a judgment call, but it's becoming more and more important to understand the impact on system safety issues when maintenance is doubtful on older equipment. Review question 5. Why does IEEE model only three-phase faults? Well, again, the reason IEEE 1584 is so popular and esteemed is that it involved a very large battery of testing that included three-phase systems. They tried to induce a single phase. In fact, they made a couple attempts to create a single phase arc, but in virtually every case, the arc migrated to a three-phase fault within 30 milliseconds. And if you look at the images that I used during the data collection discussion, if the arc plasma ball can touch an electrified bus, there's every reason to believe that the arc will migrate to wherever there's energy available. So with the current goals in mind, IEEE 1584 committee is trying to establish some single-phase arc recommendations. Same is true about DC. 1584 does not include a DC arc model yet. EasyPower uses max power method, and this allows the calculations of DC. In fact, you have the ability to extend it and even beyond the 1,000-volt scope of the max power modeling situation. Now, when it comes to single phase, in the 1584 2018 version, although it does not include a single phase model, it does stipulate that conservative results will be found if you use single phase current, arcing current, and then the three-phase modeling procedure to calculate instant energy. And then some of these other conditions are not included in the model either, but you'll find in EasyPower you can do coordination for any amount of any condition of fault profile that you want to include. The 2-second rule used to be only a rumor because it was in the informative annex. With the release of 1584 in 2018, it's become a rule per se, and consequently, it's important to understand what that verbiage says. And that is, if high incident energy is due to excessively long trip times and the work site allows a technician to move away from the arc, then it's within 2 seconds, then it's reasonable to limit the incident energy calculations to 2 seconds. But the admonition is to use sound engineering judgment. I personally don't recommend it for voltages over 240 volts. And it's a real struggle to think that a 2-second maximum is a good idea as far as max calculations. On the other hand, I suggest if you're going to use the 2-second rule, apply that max limit, you wait to do so until after you've done coordination, because limiting the 2-second calculations, the calculations to 2 seconds could interfere with misaligned coordinated devices. And it's something to play with if you don't understand the implications. The questions: do we compare instant energy current when large motors are on and off only for greater than 50 horsepower? Imran, this is up to you. This is what the suggested application is that the baseline for large motors is 50 horsepower. Anything below that, it's doubtful that it's going to contribute much in terms of instant energy increase. But certainly as a collective, comparing all motors on to all motors off will give you a sense of how much motor contribution is affecting your results. And then Tori is saying, what is the maximum time you apply for locations above 240? Again, there's no guidelines for this. I personally am, again, if we have a trip device that's not a protective device that's not tripping within 2 seconds, there's more than likely something wrong with the coordination upstream of that bus. So it would really strain my grits to sit there and apply 2-second limit just because on any voltage, unless I knew for sure that we had coordination in line. So no, maximum time according to the standard is 2 seconds on any voltage. And I hesitate to go anything beyond that. Okay, how does EasyPower handle arc flash greater than 15,000 volts? In the new standard, there's no recommendation for anything beyond the scope of 1584-2018. However, EasyPower gives us two choices. For three-phase faults above 15 kV, we have the option of applying Ralph Lee methods, or if they're open air buses, EasyPower will apply a single line to ground methodology that's equivalent to the NESI table lookup for data based on ArcPro. So if you have questions about that, contact me or look at the website. We have videos on it, but certainly you can contact me. We can discuss how that's implemented, but that's built into the tool as well. Now I realize NFPA 70E has a more recent version than 2018, but I so much appreciate this cover for what it illustrates, and I think it's important to emphasize the pyramid for what's called the hierarchy of risk control methodology. And so the bottom line is in the early days of 1584, the whole focus was on calculating PPE and making sure someone had on enough PPE to withstand whatever that energy was. In more recent times, it's been understood, or it has been recognized, that there should be a lot of attention paid to reducing the incident energy before you ever consider putting someone in harm's way, independent of the PPE. So these steps should be taken before you even consider what the PPE should be. And we're going to be talking quite a bit about engineering controls and awareness training, because it's recognized that better training and better procedures for doing electrical work can actually reduce the possibility of a fault, and putting on more PPE can actually make things worse because it reduces the dexterity of the operator. So anyway, much of what we're going to be talking about for the next few minutes is how to not just count on PPE for protection. One of those topics is mitigation. And this is not only a very useful tool, but it allows for a better understanding of how these different methodologies or options take place, and whether or not personnel should be untrained or unqualified personnel should even have access to this data. So the first is maintenance mode. So these are primarily technologies that became available when the trip units were designed to incorporate microprocessor controls. And so maintenance mode temporarily reduces the incident energy by reducing the trip time when a fault current is sensed by a protective device. It's controlled by an on-off switch either on the front panel or a control line through the back panel of a breaker. And the problem is you need to turn maintenance mode off after the work is done, because if it's left in the on position during normal operations, a transient of a large load could force a system to trip. So let's kind of talk about this more in detail. And it's important, I think it's relatively important to see how valuable EasyPower is in this regard, because it lets us look at the operations of the tool. So when we talk about maintenance mode, it's referred to by different terms by different manufacturers. But if we open up this breaker, the GE breaker data dialog box, we can see as we're setting it up in the short circuit, first of all, we want to make sure we have auto calculate. And then in phase trip, there's an extra step down here called RELT. And in GE vernacular, that's reduced energy let through. And the point being is once it's turned on, the trip setting is much quicker than the instantaneous is for normal operations. And so what that allows is a quicker response to the fault current that we expect on a given bus. And if we go into short circuit and fault all the buses, you can see in normal operations, we have 5 calorie exposure if we want to work on this bus. We have 10 calorie if we work on this panel, 22 calorie to work on the main MCC. If I turn maintenance mode on for the whole system, which may or may not be something I want to do, but it's possible to get incident energy below 4 calories for the motor, below 4 calories for the panel board, below 4 calories for the main, and even on the high voltage side or medium voltage side, I can get reduced the calorie exposure to 10.2 calories. How does this work? Well, I'm going to turn off maintenance mode. Maintenance mode can be individually turned on or off. So we're going to just turn off the whole thing for now. We're going to go in and look at these two breakers. And look at the TCC plot. And what we're doing is we're sensing a downstream fault. So if I fault this bus, double click it, look at incident energy, I can see it's my 5 calorie exposure. If I turn this motor on to this breaker to maintenance mode, to right click and turn maintenance mode on just for this one motor, you can see it brought the incident energy down to less than it was. If I turn on this breaker, maintenance mode, it brings down the 4 calories on both buses. Now, so that infers that we need to have both of these on to get protection on this particular bus down below 4 calories. And likewise, this is a large motor. If it were to fault or to trip, you can see by the TCC curve, we have the instantaneous response down here at, looks like it's 1,000 amps, 100 times 10, 1,000 amps-ish. And so starting that motor would definitely cause that breaker to trip. That breaker looks like it's BL1. So again, this information being the incident energy when we have maintenance mode in place has no business being on the label, according to me. My point is, because there may be people that are not well aware of not only a maintenance mode effect, but the arc flash in general, that may take that lack of knowledge and trying to apply maintenance mode to work on a hot bus and get themselves in trouble. So where it belongs, where the information belongs, is in the hot work permit, which gives me a chance to talk about hot work permit. So once we've gone to, I'm going to close this TCC plot, Go back to the one-line diagram. So if I want to create let's go to short circuit, a permit, a hot work permit on a bus that I've calculated instant energy, I go to the work permit icon. Now these are already set up as far as possible tasks that I want to implement or have ready for any bus in my system. If I'm going to work on large parts fed only by the direct branch of the MCC, I check that. And I'd want to change so these are the typical values for the equipment at 480 volts from the standard. But if I'm working on a feeder and I'm going to know the operator is going to be within that 18-inch boundary, I'm going to change my working distance to whatever his distance will be. And once I do that, we can create the hot work permit and have it include may have picked one. Let's try this again. Okay, let's try this one. I think I was getting a little too, let's say we're within 10 inches. It's getting a little too radical on the switch gear. Okay, so this is from a report that's straight out of 1580, out of NFPA 70E, has the ability to describe the details of the work, shows the results of the arc flash and the electroshock calculations, shows the arc flash boundary, and the incident energy at the working distance that the person's working at. And that's why this information in maintenance mode would be required on the work permit, not on the label, in my opinion. Describes the work, describes the safety procedures, and it has a place for management to sign off with an understanding that personnel have been placed in an elevated hazard situation and management's aware of it. So again, these are built in, and once they're set up, they can be used to create a hard copy of the work permit. Let me see if I got a couple questions. Okay, we'll go back to database. I'm not going to save any changes. That brings us to zone selective interlocking. So a step up, if you will, from maintenance mode is a similar time constraint reduction that's proactive in that there's communications between the breakers. So let's see what that looks like. So again, maintenance mode has got its place. It's in widespread use, and you need to be careful that somebody that doesn't know what they're doing thinks they can utilize that information willy-nilly. So zone selective interlocking is different, as I mentioned, because there's communication link. This graphic is representative of a COM signal between the upstream and downstream breakers, and it transfers a restraining signal. And basically, if this breaker senses a fault downstream, it will issue a restraining signal to the upstream breaker saying, I've got this, don't change anything, and it will trip basically on a reduced setting to clear the fault. If this breaker senses a fault and the one downstream doesn't issue a restraining order, in other words, the fault happened on this bus or this breaker's broken, then this bus will trip quicker because it's not having to restrained operation. So with that said, let me show the same display on how this works. So I'm going to look at these three breakers. So BL1, BL3, and BL4. Normal operations, if we kind of reduce this. Oh, the other thing is maintenance mode will, if left intact, will contradict selective coordination, whereas zone selective interlocking, because the manufacturer will be involved in setting the profile for the upstream breakers, can maintain coordination. So if we get a fault on this bus, the normal incident energy is just under 10 calories without zone selective interlocking imposed. If we turn on zone selective interlocking and we have a fault on this bus, BL4 would trip quicker and give us the ability to have a reduced exposure and allow us to wear 2.5 calories per square centimeter. I'm going to go back to normal operations. If we have a fault sensed on this bus, it's not picked up by the downstream breaker, then that second BL3 will be the tripping device. And again, it reduces the incident energy to 4 calories on this bus. And it will also affect the protection for the motor. And likewise, if we have a fault on this bus that's not sensed by the two breakers downstream, then the BL1 will trip quicker and protect the whole system. So the advantages to zone selective interlocking is that it does not interfere with selective coordination. It can be left on full time, and it's maintains coordination even during a fault. But again, it's a function of the microprocessor, and the manufacturer should be involved in recommending the settings for whatever load that's being protected. Okay. That's zone selective interlocking. Now, there comes an issue with arc sensing relays and differential relays in that they trigger on faults that can't be simulated in EasyPower. What I mean by that is for a differential, differential and arc relays look very similar. So I'm going to look at the arc relay setup. They're described, the zone of protection is described by where the sensors are placed. So for a differential relay, I would use CTs as my sensing element. In arc sensing relays, I use a light sensor as a sensing element. So in this particular case, my zone of selection includes the downstream switchgear. And so I have a light sensor there, a light sensor on my main switchgear, and then repeaters that relay that location's arc, or the sense picks up the location of the arc and will activate whichever breaker is least restrictive. And when I say that, when we go to short circuit focus, and look at instant energy and fault this bus, we can see we have a protection of 3 calories, even though it's 12 it's medium voltage. So if I look at a range for arc flash, I see that R2 is the protected device, and it's tripping in 52 milliseconds, and that's a recommendation based upon the manufacturer, the relay time for the relay sensing the trip setting, and then the opening time of the breaker. And so since EasyPower cannot simulate the light flash, what you do, or what is done, is we go to database setup, and for this local bus, we set the arc flash tab to be a user-defined time. And so for when the response will be when this bus faults, it will be due to the R2 protection. And this is a fixed time that the manufacturer, with some amount of buffering, would support as far as the response time of the relay plus the opening time of the breaker. Does that make sense? And so each bus would have that setting, and it may vary based upon where the system is, where the breaker opening time is, but it will give us an idea of the isolation that could be counted on for arc sensing relays. So the same is true for a differential relay, and the differential relay compares the incoming CT values with the outgoing CT results. And if there's a given size, a difference between the two, it will fault. The relay will fault usually the main breaker upstream. That time involved will be a summation of the relay response time and the breaker opening time. And again, it would be triggered by that particular fault on the bus. Okay, so that's differential relays, arc flash relays. Now, arc quenching tech is a more recent technology these days, and it's because we can't simulate its operation. It's the same kind of thing where it opens up. Well, there's multiple ways of getting the quenching, but basically it does a hard fault or a crowbar on the bus that's protecting the system, and it has a very fast trigger to redirect that current to ground and blow the main fuses. So it's real similar to a lightning rod, and it is true you need to replace the fuse, but it does protect the whole system in the case of a fault. So that's something that needs to be analyzed on a case-by-case basis, but it's something that's gaining traction in the industry. Okay, so any questions on mitigation? In the handout section, I've included the copy of this slide, but basically in the 1584.1 application note, it recommends these elements be included in the reports that's regarded as the arc flash study. And these include a description how the system looked when you first arrived, the modes of operation in the power system, the details of the scenarios that you looked at, and the results and recommendations for time current analysis, a whole list of reports. And let me get back into EasyPower and we'll talk about this. And while I was here, I wanted to make a comment on with and without motors. So if we right click, I'm in database edit. If I right click, there's a checkbox here that says include motor contribution. So right now, if I fault any bus or any fault in the system, it will include motor contribution from any motors that are affected by the fault. If I uncheck that, then it will do a calculation without the motors, and that's where the study should give me an idea which is more effective. And because there's no motors in here, it's not showing me anything. But the point is, it's a one-button selection to choose with motors on and with motors off. Okay. Now, reports. If I'm in short circuit focus, all reports show up under the list of windows. So if we are looking at current, I'm up on the top row. A half cycle current, three-phase bolted fault, and fault all the buses. Then I'd want a report that shows me those results. Under my short circuit options text output, I'd create a high voltage and low voltage momentary report. I'd create an equipment duty report. And as I do that, and then fault all the buses, under my list of windows, we'll get those reports. Because there's not any low voltage, I don't see a low voltage report. These can all be exported to Excel, exported to Word, copy and pasted. Let's go back to reports. And then detailed as far as what any exceptions that show up on the reports. Likewise, other reports that should be included include the coordination report. If I'm in coordination, looking at current, under PDC options, right-click on the bottom, create a sequence of events report. This will tell me any place I have a fault that's out of fault clearing that's miscoordinated. So if I fault all the buses looking at current, the tool will show me the sequence of events on that report. So if I go under Windows, sequence of events, it shows me every bus in the upstream. And so right now, because I did this for arc relays, I don't have any coordination for there's breakers in my system. Any questions about reports? And then usually there's some necessity to include advice or suggestions to how to do mitigation or improve the system. And these can be, on a case-by-case basis. But anyway, I suggest you download this from the handout page. Okay. One of the things that I was trying to emphasize with that cover of the 2018 version of 1584 is more and more how important training has become as far as reducing the hazards that people get exposed to and encouraging them to understand when to identify a potential hazard. The study, everything in the study, everything in 1584 and IEEE 75E operates on the principle of the four affirmative questions, and that is, has the equipment been properly installed, properly maintained, properly operated, and there's no evidence of impending failure. And training people as to what those terms mean and when to recognize an abnormal situation, and in that case, stop what they're doing and inform management of the situation, can save a lot of mistakes and errors that are caused by the lack of awareness. So it's important to identify potential arc flash, ensure that safe work practices are necessary, and then as a last line of defense, know how to select PPE and to properly use it. I like to emphasize the retraining that's required by NFPA 70E 2018, and that is every 3 years or anytime the system's changed or anytime someone is observed not employing the safety regulator work practices. And this compared to the retraining or the recalculations of the model is recommended only every 5 years or anytime there's a change in the system that affects the energy. So the important point is better training and better awareness of the hazards and how to recognize them go a long way in preventing arc flash hazard problems. Invariably, high on the list of rules that are not followed or cause for a ticket from OSHA is the improper use of the lockout tagout process and procedure. And this is what it's been reported back in 2015 that it was number 5 on the list of the OSHA tickets that were written that year. And it's the only way to ensure if you're properly employing the lockout tagout, it's the only way to ensure that you're correctly establishing an electrically safe work condition. And so it's important to train and audit and monitor the proper use of the procedure. The more complicated or complex our system, and the more robust the procedure needs to be. So the procedure basically involves testing the equipment, de-energizing it, testing it, logging out, and grounding the bus when possible, and then making sure that no one can re-energize it without the area being cleared by the person that initiated the lockout tagout. Then the topic of labels come up, and again, that's an important result of doing a study, and the stipulation in Article 130.5 is the electrical equipment such as switchboards, panel boards, industrial control panels, meter sockets, and motor control centers require a label if they are possibly will be open to examine, adjust, or service while the equipment's energized. And so this is a list of the equipment that's the necessary items on the label. By just convenience, the electroshock guidelines are put on the label as well, but they're not required. ANSI Z 535.4 includes the recommendations for standardizing the look and color scheme of labels in elevated hazard situations. There's a move afoot to eliminate the danger indication, and I have an issue with that because if you read the ANSI standard, the definition of a danger situation is there's a probability of severe injury or death if some PPE is not worn, the proper PPE is not applied. And so if you have instant energy calculations at 40 calories or even 20 calories, that could be a situation that if you didn't have on the proper PPE, you could be adversely affected. So I'll leave that discussion to the committee. So the movement is to have everything have a warning label and make sure people are trained to understand how to equate the warning label to the need to wear a certain level of PPE. And so you'll see a typical label that looks like this. showing the energy and working distance, the arc flash boundary, and then the system voltages. In addition, you may want to have more data, including the calculation methodology or the date. And EasyPower's editing capabilities, label editing, are well appreciated by anybody that has to do custom labeling. So these can be modified. Included with the tools are some 24 different templates, all of which can be modified relatively easily, and then incorporating logos and augmented text. There's also a feature that lets you put a QR code and can be utilized to disseminate information to someone standing in front of the panel that could range anywhere from safety procedures to user's manual for the equipment to updated power out notices on a campus situation. So the point is you have a fixed label, but the information available to the label can be changed literally every day if necessary. So the bottom line is labels are controlled by you. In the handout section, we have labeled do's and don'ts. The bottom line, I think, from our point of view is try not to confuse the situation with too many labels. Okay, we talked about work permits. Real quickly, a final case study. I think this was a DuPont plant that needed to have a replacement of a 480 volt low voltage power circuit breaker that had to be racked in with the bus energized. When the breaker was refurbished, it had a slightly misaligned neutral stab that wasn't recognized by the electrician as he was racking in the breaker. And as he did so, with the breaker open, nothing was wrong. But as soon as they tried to close the breaker, it resulted in a line-to-line fault, causing the primary fuses to open. This is the actual image of the breaker enclosure, and that copper patina is oxidized copper that was deposited all over the place. Well, before the fault, they had an arc flash study. They had labeled the equipment properly. They determined the PPE, and the workers were trained in all facets of it. According to the study, it predicted the 38.9 bolted fault current at that bus with a prediction of 24,200 amps arcing fault current. And at that current, the primary fuses would open in 0.8 of a second, producing an instant energy of 88 calories. According to the measured distance, it was 28 inches. And at that point, the estimated instant energy exposure to an operator would be 50 calories. Well, the electricians were wearing 100-calorie suits, and as a result, no one was hurt, but there was some minor sunburn on one of the operator's noses because of a deflection of the face shield. It was emphatically emphasized that this all happened on Graveyard, which was notorious for not properly wearing PPE. So the point to be made, and pardon me for that, is lost workday was prevented. Workers using PPE during off shifts could be improved. The hazard analysis and PPE costs were small compared to the possibility of injury. An arc flash hazard assessment can make a difference. Appreciate you all for attending today. If I wasn't able to get to your questions, I'll answer via email. And we welcome you to visit the website for other webinars and training that's available via the Bentley system. Thank you and have a good day.